there we are. Okay, with all this basically done, let me clean up my desktop a little bit. We can now make a transition to how do we get this stuff now to a 3D printer. Which one do we use? Yeah, we can use the 3D print model. Okay, there we are. Very good. So what you do not want to do is now we send this one out as an 3D print because it literally exports everything. Now we can go ahead and hide all the elements and then step by step. So now I will send out the stamp. So I go to export, 3D print, high resolution, that is really what you want for 3D printing anyway. Continue, click on share. Then you can define where you would like this to go. Let's say we send this via email, or we save it to a file somewhere. I have here my Shapr webinar folder, and then we can give this a name. I have everything already prepared. So let's go to the Shapr, and then there is the webinar. So there you have, or I have all the individual STL files, previous files, because here I have, for example, the, where is it, stamp large wall. So this is my initial print or STL model, and then I realized I need to adjust the material thickness, like the first stamp and the second stamp. On the Mac or PC. So let me go over to this. So there I have now the folder on my Mac. And let's go to the 3D printing software for the task printer. Okay. This currently is set up for the Morris extruder. The Morris extruder has 0.5 to 0.9 material height. And I will insert one file, and let's always use the same so we can also compare how the individual nozzles in 3D printers compare. And 3D printing handle, yeah, this one is good. Okay, loads a model, and there it is. Cool. So this is now a rundown, an explanation to people who are new to 3D printing. So we put this model in. Currently the software is slicing it. There, it takes a moment. I want to have this generate support on. Infill 15%, that is fine. And with high speed, this takes 24 minutes to print. So what does this generate support actually mean? In Cura, then we can go to layer view. Now we will see the individual print layers. Give me 1 second for the software to pull this up. There we are. Everything that's blue, that's actually the support. And I'm holding this into the camera now again. There you can see that is the support. That's red, the actual model, and there's the support too. Later we can take a plier and hope that nothing will break when I try to remove this support. A little wiggle. There, very good. It didn't break off. And the rest here can remove. Maybe use another plier to cut this off. There. And then some sandpaper and clean it up. Okay, good. Let's go back to Cura. 37 layers. That is how many layers vertically the printer needs with this white nozzle to print. It's actually pretty good. No? If I zoom in here, you can actually see what is red, what is gray, and that is the model. And what's gray here and not red means that can't actually be printed. That's lost. That is why, yeah, I hold this into the camera. Here, this stuff isn't there. And you can see through. There should be right at the center, there should be some holes. And essentially what this means is the printer we tried to use did not have the resolution to print this. And we go up layer by layer, and we can see how everything is being printed. For those who don't know what the support really means, you see the handle is going to be printed in air horizontally, and via gravity would pull the plastic down onto the printing plate, and that is the reason why we need to have this support below. Now another thing, because the handle is kind of like solid, you don't have to print it solid. That's the reason why we have this infill that basically takes a solid object and then cores it out. And another thing that is important to keep in mind here is while the nozzle has a height for the print, it also has a width. And so this red line is one print, then there is something in between, and there's the next layer. So the nozzle actually can print 1.2 millimeters wide. So ideally you want to make your models or the shells as wide in equal increments as the printer can print. So let's say you have a nozzle that prints 1 millimeter. Then you can make shells which are 1, 2, 3, 4, but ideally not 2.76, because it will be difficult for the printer to print. If your nozzle is half a millimeter wide, then you can go half a millimeter, 1 millimeter, 1.5 to 2.5, etc. Okay, so that's pretty logical. 24 minutes, keep this in mind. High speed, let's go to high detail. So instead of 0.9 millimeter, we go 0.5 millimeter. The width is still the same. The height, however, is different. You see now, print time actually doubled. If we go to layer view, let's take a look. These details still are not working. But if we look from the side, as you can see, we have now 65 layers. This detail looks much better. For comparison, let's go back to high speed. And come on, slice. There you see this is very, very coarse. That's why these details didn't really turn out that good. Okay, so Cura for the Ultimaker. Here in this printing software, I just put in one of the printers we also have. We can print in extremely fine layers, so 0.25 millimeters. Okay, so I will load actually a file now. So let's go to there. We will use the same file, open. So give it 1 second. There it is. Very good. All our settings here, layer height, yeah, 22% infill, support we need, adhesion we would need for that printer because it has a different printing plate. Well, I will not turn this on. So the values are somewhat comparable, and let's slice everything. And then after we're done with this, I will talk also for a moment about the orientation of a print. What's the most logical one? Also in, some economical tips about when to print how many single prints or multiple prints, and then we will go into the web. Because what do you do when you don't have a printer? There are services where you could do this. So this takes 17 hours and 10 minutes. Sorry for my outburst, but you started realizing we just switched to a different value, and we went from 25 minutes to 49 minutes to 17 hours. So that probably explains now everything to you. With all this, let's take a look at the layers. So preview. Did they put this one here? I just installed this one today. This is a new version or new interface, and I think under preview they have the layers. 548 layers. Also quite a jump there. When we zoom in there, there you can see how many layers we have. So this is an extremely fine print. A good print. This is, for example, very good then when you really know this design is perfect. Let's go and 3D print a high-res model. Okay, let's go back to the Cura, because the calculation there is a little bit faster for these coarse models. So how should you also always orient a print? I have this flat bottom, so it makes sense to line up this print this way. What you don't really want to do is have your objects rotated in awkward positions. Also currently horizontally everything is being printed, which is pretty good, because if I take and rotate this object, let's say I'm doing something that makes no sense, but this will show you why you should not do it. Let's rotate it this way. Okay. We have to slice it. Very good. Let's take a look at the layers. Do not show the support. There you can see that all these slices are going essentially, they're not parallel to the length, but perpendicular. And because these are very short surfaces, this can easily snap. Now I'm switching back to my camera for the moment, and here you can see that these layers are horizontal. So when I try to bend it this way, it's very stable. But in case these layers would be this way, I could probably easily, by accident, snap it. Here they're actually printed that way. If I take this, I mean, it's still a pretty good print. But you can see I can bend this a lot. This I can't actually bend as much. Okay. Last thing maybe to here talk about is this detail has no support, but all the rest is filled with support. So this is not really a good idea to rotate this object, because there's a lot of support I have to remove. So ideally you always want to find a position with maximum strength, nice print pattern, and least amount of cleanup. Also, you don't want to do something like this, where your object is rotated awkward, because the print layers are very irregular and crazy, and you also have support everywhere. Because with the support, we can show this maybe in this object. I will go back to the camera. So there I have the support at the bottom. Now I have to break this away. Oh, that was easy. And right here, there you can see there is a result of, or the leftover from the print stuff. The top where there was no support is really nice. The bottom kind of like has some residue. The surface is flat, that was on the print surface, perfect. If we go to this model maybe here, there we see this even better. This is now with finer supports, and there you can see that structure. Now this is not visually desirable, so print or positioning your object in the printing queue also can have an impact on the quality. So where you don't want to see these prints or leftovers, try to have the support. So here this is fine. On top and on the sides here I don't want to see it, which is why for this model this made the most sense to print this one the way how I had it initially. Can we go back? There's no undo button. Okay, maybe rotate. Reset. So yeah, so that way. That's the most logical way to do. Very good. So last step. What do you do if you don't have a 3D printer? That's actually not really a big deal. When I was a student, it was always great to have a 3D printer because these machines were very expensive. In today's time, things are very, very different. We could go simply to services like Shapeways. And essentially the question that can come up, a 3D printer today, a coarse one can cost you $300–400. No, it's not too much. The more extruder, well, that's a $2,500 machine. If you use it a lot still, it's good. If you use it here and there, it doesn't really make sense to buy your own printer. Use a printing service. Particularly if you do it for a client, you can invoice that stuff. And companies like Shapeways, they have a variety of different printers you could choose from, which is even more ideal. So we can upload a model. So millimeters, that's also the way how I exported it. So let's select a file. And which one do we need? Let's use the insert. Okay, so it's uploading it right now. Then it's processing it. Then we can specify the type of print material. In today's time, you have a variety from plastics to resin, ceramic, sintered glass, metal, and obviously also bronze cast, silver cast, gold cast for jewelry. So that's pretty good. That's fixing and finalizing the model. It's giving me a little bit of information about material, volume, etc. See, down there we have these holes in there. Okay, so select a material. Do we have to go to here? There you can see they have the resins, then steel, plastics, gold, silver. Also multicolored stuff works. So we can also gold plate something, so it's not printed completely with gold. Aluminum, that's pretty amazing. Different types of plastics. Sandstone, that's kind of like a powder print, which can be colored. So it's like 3D printing and color printing at the same time. So that's pretty amazing. So my 3D model, let's go back to there. So this one is still processing. There we are. Okay. Let's select it. And there you can see now the price overview. So if we do kind of like this plastic, it's $16, and SLA, so this very fine resin print, $30. Fine detail plastic, $12. That's not too much. But then if we go to bronze or aluminum, the prices start to jump up a lot. If we go to silver, well, platinum, obviously, steel, 23. So $23 just for this basket. But the nice thing about these metal prints is, I mean, they're metal, and then we can just go use sanding tools, sand these, and then we can have a prototype that's also maybe reflecting the actual weight.